So here is the last piece of our excursion into rational expressions. The expressions have been combined to create an equation. And we're going to solve it and find out what value we should use in order to make this a true sentence. There are several different methods. They all involve finding a common denominator, stating the excluded values. One of the methods is to do just as we've been doing. Find the common denominator, put this over the common denominator, put this one over the common denominator, put this one over the common denominator, do a mess of algebra, and solve. The method I'm going to work with is the one that's used in the AP Calc course, so that's the one I'm going to advertise today. We are still going to find the least common denominator. We are still going to state any values that make the denominator equal 0. But instead of making each piece over the common denominator, we are going to take the LCD and multiply it times the entire equation. Multiply the LCD times this fraction, and times this fraction. And when we do that, the denominators will all cancel out. It seems a little weird, but it works. So we'll try. We have 6b to the second and 6b and b squared here. We need a common denominator, something that all three of those will divide into. It looks like it's going to be 6b squared. This will divide into 6b squared, this divides into 6b squared, this divides into 6b squared. Now we could have told just by looking at it, or we can tell from the common denominator. Are there any values of b that will make the denominator equal 0? Because if there are, we won't use them. And I think you can tell that we're going to have to exclude anytime b is 0. Because if b equals 0, not one of these denominators will be useful anymore. So we're going to take the entire equation and multiply it by that common denominator. Going to take each piece, just distribute all the way across. And as long as there's an equal sign here, it is legal to multiply both sides of an equation by the same thing. I know many of you can just do this in your head, and I applaud that. I am going to write out all the tedious little steps. So 6b squared times the first one, plus 6b squared times the second one, equals 6b squared times the one on the end here. Now if I did that correctly, all of these are going to get rid of the denominator. We have 6b squared over itself, so they will cancel out, but that doesn't mean that it totally disappears. 6b squared into itself goes once, so that's going to be a 1. If we have 6b squared over 6b, that's going to reduce to just b, because the 6's will cancel out, equals, and then here the b squareds will cancel out, and we have 6. So b is going to have to equal 5. And we could check it, we could plug it in. The same thing, hopefully, will work on the next problem. But this one's not factored. That's a shame. We have a denominator of x, and these are nicely both the same denominator, but they're not factored. We can factor this as x times the quantity x minus 5. Same thing over here. Now that we've factored, are there any values we need to exclude? Any numbers that if we put them in for x, we will have a whole denominator turned into 0? Well, definitely if x equals 5, but also if x equals 0 in any one of these three fractions. So we'll have to exclude x equals 0, x equals 5. Least common denominator. Well, it's going to need all of these, and it's going to need an x. So I think the least common denominator, I would go with x times x minus 5. And that is what we are going to multiply times the whole equation. So the first ones, I multiply that times the first fraction here, the 1 over x. Now I have x times x minus 5 over x plus, oh goodness, this looks like it get interesting, this times this over the denominator. This goes much faster if you can do this step in your head. And then it's okay to multiply the other side of the equal sign. Actually, it's required to multiply the other side of the equal sign by the same thing. So we'd have to multiply times the 7x minus 5. And I'm going to use the factored form of the denominator. Now, this looks terrible. We are not going to multiply these out. If we use the right denominator, we should be able to just cancel things out. So in the first fraction, we can cancel out the x's. We have x minus 5. In the second fraction, we can cancel out the x's. We can cancel out a factor of x minus 5. And all we have left is 3x plus 10. On the other side of the equal sign, we can again cancel out those x's. We can cancel out this factor, because it's in parentheses here, x minus 5. And we are left with a much simpler equation. So we just do the algebra. We have 4x plus 5. It's got to equal 7x minus 5. And I don't know how you want to go from there. I'm going to subtract 4x from both sides. This is not usually the way I do it, but... And then add 5. And the answer is not 3/10. If we divide both sides by 3, we find out that x equals 10/3. That if we put 10/3 in this equation, everywhere there was an x, this side of the equation would equal that side of the equation. And it's solved. So do not have an assignment for this other than to work on the quiz that's going to be attached separately. The quiz covers all 4 sections of lesson 3, the polynomial inequalities, and the add, subtract, multiply, divide, solve equations with rationals. If go back and see the videos again, Look at your notes, and please read the directions when you do the questions on the quiz, and have a good weekend.